Assalamu alaikum friends. Today I'm going to teach you about double hashing. Double hashing is also a collision resolution strategy. I have taught you about hashing, that hashing is basically a technique which is used to fill in some data into data structures. If you have a large amount of data and you want to fill it into a data structure, and similarly you want to extract it from those data structures, generally we use keys. But sometimes we do have collisions. By collisions, I mean that two different data entries try to get stored into the same data locations. So, how can we resolve it? So, in order to resolve it, in double hashing, we generally use a double hashing function. You have already studied about linear hashing and quadratic hashing. In linear hashing, whenever we used to have a collision, we used to use an I number which was called the collision number, and then we used to take mod of 10, or it depends whichever hash function you are using. It can be mod of k can be any number. Similarly, when you were doing quadratic hashing, then you were using I square. For example, you had a collision here, you wanted to store another entry at this very same location. So you used to do iterations, that in one iteration you try to locate it here. If it is also filled, then you try to locate it here. So this is linear, and in quadratic you used to do those jumps. So this was all about linear and quadratic. But now in double, we are not only using one single hash function, we are using two different hash functions. And why do we do this? We use extra hash functions to uniformly distribute the keys. So this is the catch point in double hashing, that with the help of double hashing we are actually able to uniformly distribute the keys. So with the help of an example, I'm going to tell you that how double hashing actually works and how double hashing helps to uniformly distribute the keys. So okay, let's take this as example in which we are given with keys 20, 34, 45, 70 and 56, and we are given two hash functions. First hash function is saying the keys have to be taken modulus with 11, because 11, so we design a table with 10 pockets. Whenever n is whatever your value of n is, we simply subtract 1, and according to that number we design this table. So I have designed this table with entries equal to 10. Okay, so first of all, we are going to simply use the first hash function, which is h1 of k, and we are going to find out the modulus of these keys. So for 20 mod 11, we get 9. It means that we are going to store this number 20 on location 9. So you can see that I have written this number here on this data location. All right, so for the next key, which is 34, I am going to take the mod 11, and the answer is 1, because 34 divided by 11 is 3 times we get 33, and we get 1 as a remainder. So basically 1 is the modulus. It means that I'm going to store this data entry 34 onto this location of 1. All right, now when I take the modulus of 45 with 11, I am getting 1. But see, I already have stored 34 onto this location, so now I have got a collision. All right, so whenever you get a collision, then you need to resolve it. At this very stage, we have to use the second hash function, and when we use the second hash function in double hashing, we combine these two hash functions and then use them together. So this is the actual form of the together hash function that I generally use. h1 of k plus I is showing the number of iterations that I'm going to do in order to resolve the collision. I is multiplied with h2 of k, and you already know the value, the function of h2 of k. h2 of k is given as 8 minus k mod of 8. These two hash functions are generally given in the question, but just in case if you are asked to design your second hash function, then always remember that these hash functions have to be prime. By prime, I mean to say that if you are and this one is smaller than the first one. For example, if you are using this as mod 11, then it has to be mod 8, it can be mod 7, it has to be smaller than this one. So that is why this h2 of k is okay. Now I'm calculating the value of h2 of k. So 8 minus 45 mod of 8. So you know the 45 modulus of 8 is 5, and 8 minus 5, the answer is 3. So I substitute this answer 3 over here, and since this is my first iteration, so I'm multiplying it with 1. So 1 plus 3 is 4, and 4 modulus 11. 4 modulus 11 is 4. So I got the answer 4. So now previously 45 was asking to be stored in location 1, which was already filled, but now this 45, with the help of this double hashing function, the 45 can be stored in the location 4. So you can see here that on the location 4 I have placed this data entry 45. So my one collision is resolved. Okay, so now let's go on to the next key, which is 70. So when I calculate 70 modulus 11, I get 4. And you know that this is a collision because on location 4, I have just stored the previous entry which I just resolved. So I cannot store any other entry onto location 4. So in order to resolve this collision, I will again use the double hash function. In the double hash function, first hash function is the same. It is h1 of k. Its answer is already calculated. I place it as it is, and I is equals to 1 because this is my first iteration. This is my first attempt to resolve the collision. Okay, let's calculate the answer of h2 of k. So you can see that 8 minus 70 modulus 8. So 70 modulus 8 is 6 because it's because 8 when you multiply 8 8s are 64, so you get 6 as the modulus, and 8 minus 6 is 2. So when I put 2 here, then 4 plus 2 is 6, and 6 mod 11 is 6. So I get the answer as 6. And if I look into this table, so I can see that 6 was an empty location. So I placed this key of 70 into this location of 6. So by now you can see that the keys are very uniformly distributed. You do not see any type of clustering, that the data entries are getting into clusters. So this is the main point that I told you in the beginning, that with the help of this double hash function, we are actually able to uniformly distribute the keys. Okay, now let's extend this question for the last data entry, which is 56. So you can see that if I take the modulus of 56 with 11, I am getting 1, and 1 is the location where I have already stored my data entry 45, no, 34. Yes, so this is a collision. Of course this is a collision, and I need to resolve it. So we will resolve it with the help of quadratic double function. Sorry, it's not quadratic, it's double hash function. And in the double hash function, I already know the answer of my first hash function, which is just calculated as 1, and in the place of I'm going to write 1 because this is my first iteration. So for the second hash function, what I'm going to do is I have to calculate the answer. So basically what is it? It is 8 minus 56 mod of 8. So 8 minus 7 is 56, so I'm going to get 0 here, and 8 minus 0 is 8. So I will put 8 here, and 1 plus 8 is 9. So 9 modulus 11 is 9. So this is 9, but you can see that 9 is already a filled location by 20. So this is a collision. This is still a collision, and I need to resolve it. Okay, so now let's iterate it further with the same double hash function. So I can write 1 plus, now I will become 2 because this is my second iteration, and it is 8. So this entire thing mod of 11 will be equal to 8 to the 16. So 16 plus 1 is 17. So 17 modulus 11 is equal to so 17 modulus 11 is 6, but you can see that 6 is already covered, it is already filled, so it is again a collision. So let's iterate more with I equal to 3. So this time I will be equal to 3, and I'm going to calculate the modulus again. So 3 8 are 24, 24 plus 1 is 25, so 25 modulus 11, so it will be equal to 3. But you can, yeah, 3 is not filled. Yes, 3 is an empty location. So I will say that this 3 is my correct answer, and I'm going to store this data entry 56 into my location number 3. Okay, so basically this is how you have entered all your entries. So with this explanation, you got to know that the distribution is quite uniform, and we were able to place all the entries. So if I start writing down the advantages, talk about the advantages. First of all, the main thing is that all the data is entered, unlike quadratic. In my previous video, if you haven't seen it, then go and see it. That whenever we were using quadratic hash function, not all the data was able to be entered. We were probing and probing and probing and probing, and we were again and again coming onto the same locations, and we were not able to fully add all our data. But in the case of double hashing, we are actually able to fill in all our keys. So this is a big advantage. Second thing is that we do not need any extra space, unlike chaining. In the case of chaining, we used to link extra space. For example, if 34 wants to reside in location 1, and as we see that 45 also wanted to reside in location 1, so in linked list or in chaining mechanism, we had to make another additional space here to link all those entries. But right now, we do not need any extra space. There is no problem of primary clustering. I have already explained what primary clustering is. Just for your reference, I'm explaining it again, that in the case of linear probing, generally the numbers, the keys used to enter in the form of clusters. And whenever they come in the form of clusters and a new number wants to enter, there's a very high probability that that new number is going to enter into that very, very next location. Generally, the probability of entering a new number in this data structure should be 1 divided by 10 for each and every location. But this is not the case. Whenever you have a cluster of data over here, in the case of linear probing, there is a very high probability that the new entry will definitely come on this location. So this is called primary clustering. This is the big problem in the case of linear probing. But right now we do not have any such problem. We do not have any primary clustering. Similarly, we do not have secondary clustering. In the case of quadratic hash functions, we were having the issue of secondary clustering, but right now this issue is also resolved. But this secondary clustering means that two data entries which are similar, two keys which want to enter into the similar data location, they try to follow the similar sequence for probing. For example, we can see that we wanted to resolve the collision for data entry 45. So when we resolved the collision from position 1, it jumped onto position 4. Okay, and you can see that when we tried to resolve the collision for data entry 56 from location 1, it has not tried to jump on location 4 like the previous number 45. In fact, it has followed a different probing pattern. From 1, it tried to jump onto 9. Okay, unfortunately 9 was covered already, so we made another iteration, then it jumped onto data location 6. Yeah, unfortunately it was covered, so it jumped onto 3. But see the pattern of jumps, the probing for this data point, although it collided onto the same data entry location, the probing pattern is different. So this sort of mechanism, this sort of clustering, when two data entries follow the same probing pattern, is called secondary clustering. But since you can see that with this example you saw that there is no such similar probing pattern, so we see that there is no secondary clustering. So these four are the big advantages. This is, I have written as well, that if two keys are coming in same data position in the table, their probing sequence will not be same in the case of double hashing. But in the case of quadratic hashing, their probing sequence used to be the same. That is why we were having that secondary clustering issue in quadratic hashing. There is only one disadvantage of this double hashing, which is this which is existing in all types of hashing. So that is the time complexity is of the order of n, because we have to search the data element. In the case of worst case, we have to search through the complete data table for searching an element. That can be a worst case. Yes, there can be an average case, but we are writing it down for the worst case. So that's all for double hashing. If you do like this video, then do press the like and subscribe button, and do write your questions in the feedback section. Thank you very much. Allah Hafiz.